Let's review over double angles and half angles identities. So on this first example here, it says use the identities to simplify the expression. And if you'll look in this expression, you'll notice that it has sine and sine, but only one cosine, and they're all square. So knowing this, I know that it'd be easier to get all of them as sine instead of just cosine. I mean, you could do either or, but if I already got two sines and only one cosine, let's convert the cosine to sine. I must use our Pythagorean identity. Sine squared of an angle plus cosine squared of an angle is equal to 1. So if we're going to solve for sine, right, what would it be? Well, we need to solve for cosine. I mean, you could do either or, but the thing is, I want to know what is cosine squared so I can plug it in. Well, I'm going to subtract the sine squared of the angle from both sides. And now that I know this, now I can say, oh, 1 minus sine squared of alpha minus, and I'm going to put in the rest of this expression. All right, so now let's just clean it up one part at a time. We can clean up the numerator. The numerator, I see that I got that 1 there, but I got negative sine squared alpha minus 2 sine squared alpha. So that sine squared alpha, they're like terms. I can put them together. This says I have one of them, and it's a negative value minus 2 of them. So it's like saying I'm in the hole $1, I spent 2 more. So now I know I got 1 minus 3 sine squared alpha all over 1 minus 3 sine squared alpha. And I notice 1 minus 3 sine squared alpha is over 1 minus 3 squared alpha. That reduces down to 1, so that is my answer. Let's go to our next example. It says identify the expression that completes this identity. So I notice I got this binomial multiplication of this binomial. So what I'm going to do, I can use the full method. So I'm going to take the first times the first. So I got sine alpha times sine alpha. I'm going to put plus. And then I'm going to say the outers. So I have sine alpha times negative cosine alpha. And I'm going to say plus the inners. I got positive cosine alpha times sine alpha plus the last. And the last is cosine alpha times negative cosine alpha. All right, so let's clean this up. What do I see? I see that sine alpha times sine alpha is sine squared alpha. I see that I got a positive sine times a negative cosine, so that's going to give me a negative sine cosine plus a positive cosine and a positive sine. So these two here actually go to 0, right? They cancel each other out, so I could say that's gone. Now I have cosine positive times negative cosine, so it gives me a negative cosine squared alpha, and that is my identity. This is completing it, and it gives me the identity. Now let's do the next one. It says prove the following equation is an identity. We're just going to prove that this is true. And I want to look at this side first. Well, what do I know? I know that secant is 1 over cosine x. I know that tangent is sine over cosine. And I'm going to subtract. I got sine over cosine for tangent. And then I got 1 over cosine x. Well, looking at this, if I do it this way, it's going to be more work. So before I go further, what I need to do, and I just wanted to let you know, I guess I could have done it over here on the side. Could have said tangent is sine over cosine, and secant is 1 over cosine. So we could do that over here instead of right there. But there's more than one way to go about it. So if you choose to use this method, just be real careful because that's going to get messy. Let's do this. I have a fraction subtracting a fraction. So the denominators need to be the same. So I'm going to multiply top and bottom by secant here. And then this one here by tangent. All right, so now I got secant times secant, which is secant squared x, all over secant x tangent x minus tangent squared x over secant, over the same denominator, so I don't have to write it twice because I didn't separate the fractions, so we don't have to write the denominator more than once. All right. Well, I know by the identity secant squared x and tangent squared x gives me, and you double check on your identities on what it gives. I'm just doing a double check right quick. And secant squared, okay. So that gives me 1. So this is 1. Okay, it's all over secant x tangent x. All right. Well, if you notice, this identity already has secant in the denominator, so I'm going to leave secant alone. I'm going to rewrite this, and I'm going to work on the tangent. Well, I know 1 over tangent is what? It is cotangent. So now I have cotangent times that 1 here in this numerator all over secant x. And that's mine. It proves, this verifies that this is an identity. All right, let's work on this next one. This next one shows that we have, we're working with the identities of cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And since we have this plus sign and we're working with cosine identities, we know that we have cosine of alpha minus beta. So let's plug in what we know. We got cosine of alpha. Alpha is 21. Good. 21 minus. And beta is 65 degrees. And so now I can say, oh, okay. I got 21 minus 65 is 44. And it's actually a negative 44, but we know that cosine is positive. So since it's a positive, we are going to drop that, and our answer will be cosine of 44 degrees. Oh, yeah, now let's work on this next identity. This expression says, well, look, check it out. It's got even and odds. So if you notice, and I'm just going to rewrite this, we're again working with cosine identities. I'm just going to rewrite it. All right, I want to rewrite the identities. I want to clean something up. I'm just making this right there. All right. So now we're working with identities. If you'll notice, we have cosine, sine. Oops, this is cosine. So we're going to have to fix this. This needs to be a sine. I noticed that my alpha is 42 here. My beta is 18 here. Oh, I got a negative here. Since sine is odd, we're going to bring out, and what ago I said cosine is even. Cosine is, it gives us the positive because it's even. Sine is odd, so it's going to give us the negative. So we're going to pull the negative out to the front. Let's rewrite again. And now we need to work on this last part. And if you notice, the beta on this last part is not 18, it's 72. So we got some work to do here. So next, I want to go to our identities here and say, okay, I know that sine of pi halves minus u is equal to cosine of u. U in this case is 72 degrees. Since u is 72 degrees, then that means pi half is 90 degrees minus that 72 degrees. So now what do I have? I have 90 minus that 72 gives me 18 degrees. So now I have sine of 18 degrees. Ah, good job. Now we got cosine 42 degrees times cosine of 18 degrees minus sine of 42 degrees times sine of 18 degrees. Now my alphas and betas are the same. And since we have this subtraction going on right here, we know that we're going to have cosine of alpha plus beta. And cosine of alpha is 42 plus 18. So what does that give me? Cosine. So let's do the 42 plus 18. And I get 60. So now I have cosine of 60 degrees, which cosine of 60 degrees is a half. So that is my answer. Let's go to our next example. Our next example says use the identities to simplify the following expression. Do not use a calculator. So when we go to our identities, we're going to find that tangent 2x is equal to 2 tangent x all over 1 minus tangent squared x. So what I'm going to do is I want to divide this side by 2. And then since I did that, that means I'm going to be dividing it over here. So now what do I get? I get a half tangent 2x. And you could have wrote it all, the tangent 2x over that 2 and then reduce. But we're working with identities of half and double angles. So we need to just leave it like this for right now, okay? So this is going to be this, right? And if you'll look, this part here is this. The only thing is that actually have a value for our x, which is in degrees. My x is 165 degrees. And what do we know? We know it's 2x, right? 2 times x. So if I say 2 times that 165 degrees, I get 330 degrees. So now let's plug it in. I got half tangent of 330 degrees is equal to my half. And tangent at 330 degrees is negative square root of 3/3. And then multiply straight across. We get negative square root of 3/6. And that is our answer.